Okay, you have the graphing calculators out for a reason, because we are going to be talking about gravity in this equation, and that forces a parabola to look kind of like this, where you launch it from some distance off the ground here. That's called the y-intercept. It reaches its height, which is called the what? The maximum, which is also a vertex. Yep. And then you could say, I want to know the time at like times 5 seconds, and then follow it up and figure out what that would be. That's called second calculate the value. You're going to be able to do that on your calculator if you aren't already able. This one was the vertex, but we don't actually say find the vertex. We find the what on the calculator, the maximum. To get this, that is also a value. Think about it. It's a value where x equals what? Yes. Let's find the value where x equals, remember me saying x equals Blinky? That was on the screen the other day. So if you do value, you can calculate the value. It'll have an x equals and it'll be blinking. And you drop in a value. That's x equals 0 at that spot right there. Okay? And then the last one is this, which is not called the x-intercept. It's not called the root. It's called the 0. In your calculator, if I were you, that's actually pretty good notes all compressed into one little spot. All the things that you'd be asked about a real-world parabola. All right, and to write the equation for it, you would say y equals negative 4.9, because that's what we use for the gravity part of our formula if we're on Earth. And then we'd say x squared, and then we'd say plus, let's say 5x. Let's say that I was going to toss this marker up in the air. Okay? And I'm going to toss it up in the air from 1 meter off the ground. Notice this was in meters, so then whatever I put here is in meters, and here's in meters per second. I start with my marker 1 meter off the ground. That's about 3 feet. Okay, so it's like here. And I toss it up in the air, and then it hits the ground. If you didn't notice, that made a parabola. And if I happened to time it just right, I launched it at 5 meters per second. Okay, and that would be the formula for it. Now, in the old days, to find the vertex, you'd have to complete the square, the vertex CTX, or CTS. All right, and this, though, is the maximum with the calculator, and it's so much easier. You just got to know how to do that. Go to the left of it, go to the right of it, go on top of it. All right, so I want to do one of those with you, so I'd like you to put in this equation right here on your calculator. Pause for a second while you do this. Okay, I've got it typed into my calculator. Now I'm going to hit graph. And as long as my graph is in a decent spot, I can see my parabola. Now, if it wasn't, I'd have to hit... Well, Zoom 6 is a pretty good one to get you kind of back to a normal zoom if your window is all messed up. And now, what if I really want to see one area nicely? I'd like you to try this with me. Everybody do zoom box, Z-box, the top one. Do you get how when the TI creators are making their menus that they take the things they think are going to be the most popular and they put them at the top? Do you get that they thought that Z-box would be very popular? You know what I mean? So, learn how to use it. It's pretty powerful. Okay, now what ZoomBox does is it brings up a little plus sign, which you go to the upper left part of the area you're going to box in, just like I just did there. Okay, now I'm going to hit enter, and it starts my box once I hit enter. Then I'm going to go to the right. Can you shut that door over there for me, please? Thank you. I'm going to go to the right and down, and I'm going to box in this area. This is really an awesome way to get a good window. You go far enough out so you can see the thing you want to box in. Then you box it. You zoom box it. The second time you hit enter, it actually zooms in on the area you want it and makes a really nice graph. See how zoom box could be handy? You boxed in the area that you wanted. Now, I signed you up with a partner. I can see already there's somebody who needs technical help, and I want to get you working with that person. So I'm going to pause for a second while we do that. Okay, so now, do you all have a nice, pretty parabola framed on your calculator? All right, now I'd like you to try doing the maximum with me. Everybody go. Second, calculate. It's right above the trace button. Maximum. It's the fourth one. I'm going to hit a 4. Okay, now it says left bound. You got to read its little directions. They pop up right here. Okay, left bound means we need to make a left boundary. So you go to the left of the spot you care about and hit enter. Right bound, you go to the right of the spot you care about and you hit enter. And then the last one is guess. You go right on top of the spot you care about and you hit enter. There we go. That's my maximum. At 0.51, I have 2.27. Raise your hand if you got that. Okay, good. Now, here's the scary part. A lot of people really don't know any idea what those two numbers mean. But think about it in the context of the question. It was a marker that I threw. I was starting 1 meter off the ground, which, by the way, was this spot right here. Then it went up and reached its highest spot, which is the spot we're at now. That's the highest spot. So what is this? The number of chickens in Bolivia? Yes? 0.5 seconds. Very good. So about a half a second, he reached its highest, which was, what's that? Yes. 2.3 meters. Very good. So it went up about, 6, 7 feet, and then it went back down again. Okay, that's pretty close to what actually happened here in class. All right. So the same exact process as that is used to find the 0. Now this time, I want to have you show that you really understand how to do this by, I'm going to have everybody try it once, and then in a moment you're going to have to demo to the person on your left or the person on your right how to find the 0 or to how to find the maximum. All right, so pay attention so you understand how to do it so you can demo it to them. Second, calculate the 0. It's number 2. I'm going to hit the 2 button then. Okay, left boundary. I'm doing my 0 now. That's way down here. The 0 is the root, the x-intercept, etc. I'm getting it to the left of it, which is also above it. And then I'm going to go to the right bound, right of it, which is also below it. And see how I've got my little lines and my 0 is in between those two lines? The last one is guess. That means guess where it is. And I think it's about there. And I hit enter to lock it in, and it says 1.19, comma 0. Did you get why it should be 0? Does that make sense? The height is 0. That's when the marker did what? Hit the ground. Notice it's not where the marker hit the ground, when the marker hit the ground. Quick, go to sleep or what? Okay. So, in the context of the question, what is 1.19? And don't say the chickens in Bolivia. Yes? How many seconds that? The chicken's lifespan, or what is it? What was in the air? The marker. The number of seconds the marker was in the air. Excellent. Okay. Any questions? All right, then. Here's what you have to demo right now. Person that is on the left of the two people, or in front of, in your case. Pay attention. Person is on the left. Raise your hand. Get the person on the left. Acknowledging it's you then. Okay, good. You are demoing to the other person how to find the maximum. Show them. Put your calculator out there. Show them. All right, good. We got that one explained. Now, person who is on the right, please raise your hand. Or the person behind. All right, thank you. You are going to explain to the other person how to find the 0. But this time, do it to the other 0, where there's negative time involved. Show them how to find that 0. Go. Okay. How many of you were able to successfully explain it? All right. Still working on it. Okay. All right. Now, why do I ask you to do that? Because, number one, some people are too shy to ask or to admit that they don't really know what's going on. By having you explain it to them, or vice versa, it becomes clear whether you get it or not. And the other reason is, did you know that you will remember up to 90% of what you teach somebody else? because a different part of your your brain engages when you are teaching something. So you will remember this way better if you just explain it to somebody else. Like me just explaining it to you and you just listening, you'd think you'd remember it. 10% recall. You only recall 10% of things people tell you. If you actually explain that thing to another person, you're jumping to about 90% recall. Okay, so now I want to ask you to go to a spot. Now this only lasted for 1 second, so I want to know, where was the marker half of a second? No, let's go with 0.75 seconds. 3/4 of a second in, where was the marker? Do you already know how to do it? Raise your hand if you think you already know what to do. Awesome. Go there by yourself first. Make sure you're confident you did it right here. 0.75 seconds in. 0.75. In case you didn't know, here's what you should have been doing. You should have been going second, calculate the value, and it brings up x equals blinky. And x is time. So it's saying time equals 0.75, and hopefully you got the answer of 1.99. Raise your hand if you had it right. Okay, good. Now, I'm going to give you a real-life scenario, and I want you to try to answer this question. Imagine that this was a ball that was going to be thrown off of a cliff. First of all, let's go over here to the y equals. And would we change our gravitational constant? Thank you. Not unless we were going to go to a different planet. And I want to pause and talk about gravity for just a second here. All right, so I wanted to talk about gravity for a little while, and we did. But now I want you to change your equation. Everybody get to the y equals screen, and we're going to say that this is going to be a ball that is being launched from a cliff such that it is 180 feet up on this cliff when the ball gets launched. The ball itself. And thank you, we'll change it to meters. Good point. So let's go to 180 meters. I hope you know what to change that. Next, this ball is going to be launched upward at a fairly fast pace. Okay, we're going to make that ball go at 75 meters per second when it gets launched. All right, so hopefully you knew where to change. I hope you didn't mess with gravity because we are on the Earth. So we're going to go over here and change this to a 75. So I'm going to go insert a 7. Or you could have done that just by retyping it. And then I'm going to go to 180. All right. Did you have the same thing as me? Now what happens when I go to the graph? I can't see anything because I am all zoomed in, right? So now we have to be smart about this. Option A, we can just keep zooming out over and over and over again. It does work. Let's try that just to show you. Zoom out. And by the way, the first time you hit enter, it does nothing. It's waiting for you to say, where do you want me to zoom out? See, you can move this plus around and say, I want you to zoom out in this area. But, you know, we didn't need to zoom so far out, it really doesn't matter. So I'm just going to hit enter. And now I'm zoomed out once. And did you know that if you hit enter again, it'll zoom out again automatically? I just have to keep hitting enter, see? And it's zooming further out. And you're probably zooming in. And enter again. I'm further out. I'm zooming out further. I'm on my 4th zoom out. And I'm starting to see near the top of it now. Okay, I'm going to hit zoom out one more time. And okay, now this is just, I can't even see anything. Oh, wait a minute, I can see it barely there. Okay, so now, guess what I'm going to do? I'm going to go back in and zoom what? Zoom box. Zoom box the area that I want, which is basically about there. Enter to hold the spot, and then box in all the way down so you can see the thing hitting back down to the earth. Enter, and I'll see if that worked. All right, I'm going to pause while I answer a question here. Okay, so mine came back, and the problem was I guess I can't see the top of it. I must have chopped off the top by accident. Now, here's where you have to understand your window. Everybody hit the window button. Do you get that I need to go higher? Does X control higher? No, Y controls higher. And do I want my Y min or my Y max to be changed? Y max, my biggest Y, is currently 320, and I wasn't able to see the top. I'm going to make it like 400. And just try it and hit graph and see if you like the results. And if you don't, you go back and change the window again. I still can't see the top. Rats. So I go back into the window, and I say, well, I missed last time by, I'm going to not go just a little bit more. I'm going to go a lot more. I'm going to go like 600. Because it really isn't a big deal if you miss it. You can always change it. Hit graph. It's okay that it's taking a while for us to see this, because that's going to happen to you in real life. When you're on the test, you'll have to adjust your window like that. You'll have to know things like zooming out, zoom boxing, the part that you care about. All right, good. So now, do you get, if this was really a ball being shot from the top of a cliff and going up in the air and coming back down again into the water, for instance. Let me pause for a second. Okay, so we're going to talk about what kind of questions could I ask you. This ball that was being shot, do you get that I might want to know how high the ball ever got? Use your mad calculator skills and figure out what's the highest this ever went. I'm going to pause while you try that. All right, so here we go. How high was it? Well, you go like this. Second, calculate the maximum, and then I got to get to the left of it, and I got to find my little mouse, or my little, there it is. My little, I call it a spider, but then I'm going to go to the right of it and hit enter. You go right on top of it, and you hit enter, and here it is. Did you get 7.65 goes with 466? Now, what does that mean? What does that mean? You may have something wrong in your equation. Just look at your equation. Okay, so that 7.65, that's what? 7.65 is the time. How about the 466? What's that? The height. So the ball reached a maximum height of what? 466. When did the ball reach its maximum height? 7.65 seconds. Okay, I want to know where the ball was at 9 seconds. That's under second calculate. Value is correct. X equals blinky. X is time. Hit 9, enter, and what did you get? 458.1. It's pretty close to its max right there. Okay, so then that begs the question, when did it hit the ground? If it's about halfway at 9, I'm guessing it's around 18, but how do I find out when it hit the ground? Yes, ma'am. Second, calculate the 0. 0, because we can't find x-intercepts on this, can't find roots, but we can find zeros. And now I go to the left of it. There, I'm to the left of my, the 0 is about there, right about there. But I'm going to the left of my 0, I hit enter. Now I go to the right of my 0, I hit enter. And then I go right on top of my 0, which that's about as close as I can get, and I hit enter. And did you get 17.4 approximately? So that means 17.4 seconds later, the ball hits the ocean below the cliff. Okay? All right, so that is a typical question. Oh, one more thing they could have said is, what height did the ball start at again? There's two ways to do it. You could go, just look at your equation. It says 180 right there. That's true. But what if you're on the graphing screen and you need to do it a little more creatively? You could say, I want to second calculate the what? Value at x equals what? 0. And then it'll tell me, boom, 180. See? Okay, I think you understand everything that you need to know. Now, the writing equations part is really the really easy part. If I had given you this equation like this and said, but I wanted the I wanted the velocity to be 25, do you get you'd write the same equation except where would you put a 25? In the middle where the 5 is. That's where the velocity goes. And let's say that the height was instead like 6. Change the 1 to a plus 6. Yep, that's all there is to it. Unless we change gravity, that's not going to change. Okay? All right, so your homework is to finish the worksheet I gave you yesterday, and I said to skip some. So go back and unskip them. Do those, and then you only have to do 5 on the next worksheet. 1 through 5. It's normally longer than that, but we decided to add an extra day of work on this so that it's less rushed. And then we're going to just test on the last day before break. So you're testing on Wednesday instead of Tuesday. That was the original plan, was to test Tuesday. We're testing Wednesday of next week. So we have Monday as one more day of kind of instruction or kind of review. Tuesday is definitely review. Wednesday the test. Okay? And the test is going to be questions like I just showed you there, where you're going to say things like, okay, how high was it? Okay, one more thing that they ask on the review worksheet that I didn't cover was this. What times did the ball reach a height of 400? At what times? So in other words, they're not telling you x, they're telling you the y, the height is 400. Let me show you the easy way. Everybody go back to the y equals screen. Go down. I know you missed some stuff, and that's probably why you have questions. But if you watch the video for this, it might help you catch up with that part. I'll come to your question in a minute. So this is the height. Y equals means height. If you want a height of, what did I say, 4 or 5? 400, then type in 400 right there. Y equals 400. And it's going to put a line in on your graph. Don't talk, please. It's going to put a line in at 400. Do you get that the spots where these two touch is when the ball is hitting 400 feet right there and right there? So it hit it once on the way up. It hit 400 feet on the way up, and then it hit 400 feet on the way back down again. Does that make sense? How do you find those spots? You find those spots with second calculate the intersect. Let me show you how to do that one. This is the last one you have to learn. I know it's a Friday. I know it's the last hour on Friday, but stay with me. You got to know this for the test. All right. So everybody go to second calculate the intersect. It's number 5. You want to know where two lines intersect. Now here's the thing. This computer could automatically tell you that, but it's programmed so that if you had 5 lines on here, you could tell it which 2 lines you want to look at. But since there's only 2 lines, you can do this part really easy. You just arrow over till you get the spider right near where the 2 lines cross that you care about, like right there. And you hit enter, enter, enter. Enter, enter, enter. 3 times. And that says intersection. 3.9555 and y equals 400. Remember, y is the height. So that means height's 400 at 3.955 seconds. Did you get that? Okay. If yours doesn't say 9, is that 3.9? Maybe I'm having time reading it here. Does that say 3.9 or what? Oh, okay. I'm sorry. I'm up close here. Looking at my smartboard, it looks like a 9. So 3.955. If it's off a tiny bit from somebody else's, understand that your calculator is not actually super accurate at this point. It's trying to read the pixels on its graph. It's not like a calculator is supposed to be, where you just can always trust the answer is exactly right. It's kind of estimating, so that means your calculator and your friend's calculator could be a teeny bit off from each other. But they're so close that you can write down either answer on the test and you'd be fine. Okay? Was there another place in time where it hit 400? Yes, and the other spot was over here. So everybody please try to do this yourself. Second calculate intersect and move the little mouse thing or the little spider thing over to the other spot and hit enter, enter, enter. I'll show you that in case you're having trouble with that. Second, calculate the intersect. And then you move the little spidey over until it's by the other one, and then you hit enter, enter, enter. Do you get 11.3? Good. All right, now I know some people were not necessarily following that, and it's a really important skill for you to have. So I'd like you to just change the problem a smidge, and I want you to demonstrate to the kid next to you. And if you're not able to, they'll help you, because I guarantee you out of two of you, one of you probably knows how to do this. So everybody, please take your calculator, change your line to y equals 380, and then tell them the first time that it hits 380 feet. Change it to 380 instead of 400. And I want to know the first time it hits 380 feet. Demo it, show it. You both can show each other. If you both have the same answer, you both know how to do it. If you're having technical issues, ask me. Okay, that's all I have for the video for today.